All right, so today I'm going to be doing a deep dive on the Pwnkit exploit and vulnerability as described in this blog post by White Source Software. So the exploit that I will be going through is this exploit here on GitHub. All right, and so what I noticed in a lot of these demos of this exploit is that they will just compile and run this exploit, right? And there hasn't and for these other demo videos, they don't really sort of break it down and go into the details in terms of how the exploits actually work. So I'm hoping to provide that level of information, is to actually go into the details in terms of what's actually happening under the hood here, right? So what is Pwnkit, which is where the vulnerability exists? It's in this binary called, I think it was like PKexec. So this is the actual binary that has the vulnerability, and in it, and it's a set UID vulnerability, has that permission. So it runs it as root privileges, right? And the vulnerability, so what PKexec, it's sort of very similar to the SU command, where it allows you to run a program with privileges of another user. So that's what the PKexec command does. So where is the vulnerability? So the vulnerability exists in this main function right here of that binary. So what's happening is that for a normal execution of this program, right, you would specify a program to run. So it will have at least one or more arguments, right? When you run PKexec, that's sort of how it's designed. But the issue here within the code is that it assumes that there's going to be argcs, there's going to be arguments to the PKexec. So the code here, what happens is that this first for loop is that at first it sets the variable n to number 1, and then it sort of parses through all of the arguments, right? But what happens if your argcs, that means you have 0 arguments. That means this loop will just exit out, and then n will be equal to 1. That's what's going to happen. And after that, right, so even though you didn't give it any arguments, n is equal to 1. And then what's going to happen afterwards here at line 610 is that arg v and n is equal to 1. Basically, you're doing a read from a memory location that you haven't validated. In this case, it's going to be arg v1, which is your arg v is your environment variable that's given to your program. And so that's going to be the second argument, right? So offset 0, then offset 1, right? So it's going to read the second offset there of this array, and then that's where it's going to get the path. And then the other part of the code later on is that right here at 639, right, it's going to do a write to that variable as well. In this case, it's arg v1, and then there's going to be a write there as well. So basically, you have a read and a write that sort of, there wasn't any sort of validation, right, that those memory locations are actually legitimate. And the part I believe that actually does some of the magic of getting you some type of code execution is this find program in path. So with that, I believe now is a good time to, I think it would be good to sort of kind of explain it all, and then I can actually walk through the steps, right? So right here is sort of a diagram of what the stack will look like. So in a normal stack, first you'll have your arguments, which is your argvs, so all your different arguments. So I think I explained the environment stuff a little bit wrong, but I think I'm going to clarify it here. And then after that is the actual environment variable, which is here is envp, right? And I believe the reason that the code vulnerability happens is because we don't give it any arguments, and then it will start processing the environment the environment array that we give it, instead because assume because of the way the code logic works, it's assuming that this is actually this. So that is what we're working with here, right? Where instead of executing arguments that you give to that PK exec, the program will actually execute stuff that you give in the environment variable. That's what's happening here. And I think the last part, so this right here is showing, for normal execution, this is what it's going to look like. argv will have these kind of options, but in our case, we're going to put all of that in our environment variable instead, right? So that's what we're going to do here. And then, so the next question is, how do you go about setting different environment variables and different paths to actually get your payload to actually execute? And so here, and I can really show that really quickly. And the payload is like a very simplistic payload that's very common in these privileged escalations for Unix-based systems. So basically, you're just calling a set UID and set a GID to 00, and then you're calling ben show, right? So this is the binary, this is the code that we want to execute our payload. And then, so going back to the article really quick, right? So how do you go about doing that? By setting different path routers. The key here, what we get to work with is we get to use this gconf_path. So we get to use this functionality. And the reason we get to use that functionality is because this function is being used in the actual code for pkexec. This iconf_open, it uses this particular variable as a part of its functionality. And if you're curious about that, right, you can do iconf, right? So if you go to the BAM page of it, in the description here, it explains what happens if you go about setting this path variable, right? So yeah, so according to this documentation, these are the different things we're going to set here. Our path variable here to this really funky value, and then we're taking advantage of that. If this is set, then it's going to try to find the binary to execute from that actual path, right? So that's what's happening here with this description about gcon path. So the thing that's really interesting about here is that for path, right? Path, you usually set it in here. I think I can show you an example here. Environment grep path. Right? Path is usually this, right? Different subdirectories. It's just a listing of different subdirectories. What this exploit is leveraging, on the other hand, is that it's setting path to an environment, right? So it looks like, hey, wait a minute, that doesn't look like a normal path. So we're using this weird behavior here where we're actually trying to set an environment variable, but then we're creating a directory with that same name as well. So we're taking advantage of this weird type of behavior here where, yeah, the variable, the environment variable is going to be the exact same as a directory we create with that exact name itself. And yeah, I think those are the big steps there of how you actually exploit it, right? So I think with that, I can then now jump into the actual exploits. And later on, it kind of explains more of the details about how you use details of this gconf. And in this case, it has to do with how it goes about parsing UTF. And we leverage that to actually get our code execution there at the very end. All right, great. So with all that explanation, we can go about running our exploit manually. And what I did, so check this out, right? So this was the original exploit code here, right? So in this, the original exploit code itself, it does all the steps of in one program, right? It runs systems to create all the different directories, right? And yeah, and then compile compile your libraries as necessary, and then set your environment, and then exec it. So for me to try to get a better understanding of it, what I did was I broke it down to actual instructions, right? Individual commands. And then I ran these commands individually instead. And I think that will give you a much better understanding of how all the pieces of this exploit actually works, right? So let's see what we have to start to work with right here, right? So right here, just sort of different C programs of the exploit itself. But let's run the first command, right? First, we create this directory, we create that one directory, and then in that directory, we create our executable here. And in this case, it's Pwnkit. That's going to be the binary that gets executed. So we have to make sure it is executable. Great. And then we make another directory here, Pwnkit. And we make that one. And I believe that's the one that's going to be used by this gconv settings, right? To actually get our stuff to execute. So right there, we create this module. Let's just check on it to make sure. Gconv, right? So there's these different settings. And I think, I was going through the article in the man pages. It kind of describes what all these different parts actually mean. And then I'd have to copy that to that, yeah. And that's actually compilation of the shared library. So Pwnkit. So I think for me, I guess called mine shell. So what I'll have to do is I will have to copy shell.c over to Pwnkit, Pwnkit.c, okay? And then we compile it, and let's just make sure our shared library is there. Nice, it's there. So everything's in place. Yeah, I think everything's in place. And then now I can show you my wrapper. So basically just the last part of it, right? Wrapper.c. See, in the last part right here, right? We're just setting our environment here. And the second part is the key. This part is the key where we're setting our path is this thing right here. And even though it looks like an environment variable, it's actually a directory, right? So we do an ls here, right? We have this really funky directory there. And then it goes in there, and then, yeah, it does different parsing of this gconv to finally execute our stuff in Pwnkit here, in our shared library. So let's compile that. All right, wrapper, exp wrapper .c. All right, so and then now we run the actual exploit, right? ID, now we're root. So that's in a nutshell of how it works. Really cool vulnerability, and I really like sort of all the pieces that the researchers did to figure out. It's like, okay, now we're at this part, and then we have to find some mechanisms to get our actual payload to run. What can we use? And what is available, and this is where Nathan's explanation about reverse engineering and understanding, okay, what is our target application, what is in there, and what we can use in there to actually get our final results here of getting root execution. And so with that, I can stop my presentation.